get my pen real fast.
Oh, I did most of
Very nice. Okay, in number 7 and in number 8, let me scroll over just a little bit. Question, kiddos. Were those even roots or were those odd roots, 7 and 8? Even roots. That one's a square root of 36, right? And this one's an even root also, right? I know, with the mouse it looks kind of funny. I don't do such a great job. On the iPad I do better. Now, you guys are used to square roots, right? Square root of 36. Most of you probably put down what answer? 6. Now, you're right. Positive 6 times a positive 6 is a positive 36. True? But is that all the answer?
No.
Or all the answers, or the only possibility? What if I say a negative 6 times a negative 6? You should tell me, oh, that's also positive 36. A positive times a positive is positive. And a negative times a negative is positive. So for our purposes right now, when you go higher in math, you kind of start learning about how sometimes we are able just to give a positive answer for the type of problem given. But for right now, we're just saying, hey, what times what is 36? Well, positive 6 is and negative. Now, you guys, I don't know, maybe you don't know. Mathematicians, we love shortcuts. We love shortening how things are written. Like a word problem. It could be a whole huge paragraph, and we're like, whatever, here's an equation, let's solve, right? We don't like writing a whole huge paragraph. Same thing here. They don't like writing 2 answers. So what do? They say 6, but plus or minus, positive and negative. They're saying there are 2 answers, but we're too lazy to write it twice. Thanks, kid. Why are you shaking your head?
I have a question. So, for number 7, 6 was not the answer?
For number 7?
Yeah.
6 is one answer. So Alan, remember what I was just saying? Mathematicians are lazy. Positive 6 is one answer. Negative 6 is a second answer.
Okay. Do I put the second answer?
Yes, please.
Okay.
Because that way we are ready for when the test comes. It's okay in your pencil. Go ahead and just put it.
Okay.
So you could put positive 6, comma, negative 6, or you could just shorten it. Here's a new notation. Plus or minus says, hey, they both work. Now, kiddos, on this one, hopefully you guys factored 81. Did you figure out?
Yes.
Yeah.
Yeah, it's 9 times 9, which is 3 times 3 times 3 times 3, or 3 to the power of 4. With even roots, and even roots only, we are canceling out those 4s, but we have to say, you know what, 3 is great, but guess what? It could have been a positive 3, or it could have been a negative 3. You guys get the notation now what those mean?
Oh, so if it's an odd number, it has positive.
If it's an odd number, it has the sign of the number in front. If it's an even, then it has 2 options, right? Okay, let's roll down a little bit over on this side because you guys are still needing to check your homework for a couple more problems. Oh, I just lost them. That's
Oh, no.
It's okay, we got them. All right, you guys kept checking? Keep checking.
I got 22 right.
Wait, what?
Oh.
So whenever we have pairs, like it's the 4th, it's 2 pairs. See what I mean? If it was a 3,
So the 4 and the 3 we would have.
Okay. Well,
Diego, this is what I need you to do. Do you have a question? Someone else might have a question. Listen. Go get up during class.
where's 19?
I don't know how to do 21.
It's not right there.
Number 19, I realized online, number 19 was shown, but on the board, number 20 was shown. So I went ahead and left number 19 off. I'm not going to require it. Some of you did 1 extra problem. But wait. Number 19 is odd, yeah?
Yeah.
Wait. Where should you be checking your odds? In class?
It's
In the back of the book, yeah? In the back of the book. What was the name? Oh, and bold this. Got it. Thanks, John. All right, kiddos. Did anybody have any questions on the ones shown here, 9 through 23? Okay, Diego has a question on 18. Any more questions? Just 18. All right. Okay. Let's go check these ones out. 13 through 18. Let's look at them just real fast. These are the ones that we were working on towards the end of class yesterday. 13 through 18, our job was to evaluate, which means basically simplify. Okay? Now, hold on, I'm not gonna do all of them. Let's peek at number 18 first, and we might look at one more, because I had someone say that this section was hard, and it was. Josh, you okay? Oh, you're just asking for a pen. Hold on, Robert. What, look, what root does 1/2 show? If we were to change that into radical form, how would we write that?
Well, you
I can't, this is exponent form. How can I write it like one of the funnies?
It's not a real number.
That's good, but some people didn't see that. They don't know why. So we're trying to write it in a way that's easier to see than the 1/2. Okay, good. So it's a square root. Now hold on. Do we actually have to write? We don't have to put 2. It's understood. But does that make sense?
Yes.
Okay. The 2 means a square root, and then we put a negative 64 to the first power inside. Now, square root means 2 things multiplied together. Kiddos, who times who is 64? But wait. Can positive 8 squared make negative 64? Nah. Okay, hold on. Can negative 8 squared make positive? Wait, one more time. Can negative 8 squared make negative 64? No. Because a negative times a negative is a positive. Well, if it can't be a positive 8 and it can't be a negative 8, guess what? It's nobody. Now you can do a cool shortcut notation. This means no solution, a 0 with a slash through it. Or we could say no solution or no answer.
Which means by the property A is negative and
No. There's no way to get it, Josh.
What's the answer so
Yeah. Let me clear this ink real quick. And then go back here. Oh, no, up on the screen, see? I hit clear ink and then it gets rid of all the writing.
I said clear sync, yeah.
Oh, clear this ink. Alright, any more questions? Oh, Justin, you were wondering on these ones anyway, huh? I think number 17 was hard. Can we look at him real fast just to make sure we're tracking? Alright. Now, I'm not going to go through all the work. You guys were supposed to take 128. Jay, did you figure out the total factorization of 128?
What number?
Number 17.
17. The total factoration.
Like, factor it out. What'd you get 128 to be?
Oh, well, I got 2.
Oh, 2 to the power of 7?
Yeah.
Cool. So when you do your little factoring tree, you should have found 2 times 2 times 2 times 2 7 times. It's kind of crazy. Which means, remember Justin, this exponent form can be rewritten as the 7th root. Because the 7, whatever's in the denominator, comes out.
Oh yeah,
Good. 128 goes under. And then some of you guys are seeing, well, if we factor it, we can change 128 for 2 to the 7. You guys see what I'm doing? Let's substitute 2 to the 7. Now, hold on. We just learned that whole plus or minus thing, right? Yeah. Well, wait, with the whole plus or minus thing, does that mean our answer is plus or minus 2? Is it plus or minus 2 or just 2? Just 2. We only have to worry about plus or minus when we have an even root. We have an odd root, so we can just cross out the 7th root with the 7th power and say just one answer. And that's what our notes were saying yesterday when we were, hold on, I have to go back a couple pages, okay? Our notes yesterday when we were talking about the properties, which you guys have these in there. Now, sadly, I accidentally downloaded the wrong file and it's not written in. But the properties, I know, struggle. We should sue, right? Just kidding, don't sue.
Yes. I agree.
You wouldn't win that one.
100%.
But coming back to properties, look. Remember how we filled in properties of if n is odd, we have one answer. If n is even, sometimes we either have 2 answers, plus or minus with the positive, or no answers. Okay? That's what's going on here. Since we have, let's get rid of this guy. Oh, he's not getting rid of. Can I go this way? There we go. Since we have an odd root, Justin, just 2. But does that make sense what you're doing?
Yeah.
Take this number, break them down with that factoring number we were doing yesterday, break them down, divide them by 2, divide them by 2 again, and then see how you can simplify the radical. Alright, cool kids, let's go back and finish checking our even. Sadly for today, those are all the questions we can take on this homework. If you have more, I'm here during lunch or after school, and guys, that's when I'm here every day. You can come in and get your questions answered, okay? So here we go. We see you scroll down and finish on up. Here's the end of why is it still writing? That's kind of lame. Here we go. Why is it still going? There we go. Where's the rest? Go ahead and finish checking your evens. If some of you are checking odds, that's okay, but we could be saving time if you guys do it at home. Plus, you're supposed to be seeing if you're right as you're doing homework, right?
I got all of them.
Which one? 27 Ian's?
No, I got confused. I was telling Alan that I got confused.
Oh, struggle. Yeah. Well, that's where it really shows them. Sorry,
The
buddy.
last one?
The last one is 1 over 243 if it's too small. 1 over 243. All right, kiddos, if you have any more questions, remember, come talk to me. We got to go through a few of the questions, but we got to move on to our notes for today. I'm going to go ahead and have you guys turn in your homework now, and then if you have a question and you want to come in after school or during lunch, I'll let you look through the pile, pull out your homework, and ask me with it then. Why do I do that? If I tell you to hold on to your homework and ask me, you might forget, and then I think your homework's late, and that's stinks, right?
Yeah.
So, is your heading on it? Number 1,
Wait.
name, period, homework number. Cool. If it's ready to go, kiddos, pass it back to me.
Thank you. I didn't go then. I tried to do my scratch time.
Now, some of you guys have been checking RenWeb in order to see if you have any missing assignments. Just keep passing them back and over to me.
Nice. Or like,
Any more homework? Diego, pass it back to me. Any more homework? All right, kiddos. Let's go back to our notes. Notes open. Any more? Kiddos, I gotta do it. Shush. Well, because people are talking, right?
I want to just burn
Fernald, I can get on my air horn app. Do you want to do
No,
that?
that's
I like air horns.
Okay, so we've asked you to
Wait,
do
get an air
it.
horn.
like a truck.
Yeah, get an air horn.
truck, like,
You should get much
you know, we're shot callers.
We need to, could you guys listen and quiet it down every time? Okay, eyes on the front. You listen to him.
Jackson.
But you didn't quiet down.
You just
Good job.
I
All right, eyes on the front. Ready to go help more homework? All right, guys, so remember, I'm recording. Here we go. Section 6.3. We have 15 minutes for notes and examples, and hopefully, if it's so fast, you guys already did the bulk of the notes. Maybe we can actually start homework for once. It's been a while. But if we get our system down, we can actually be starting homework in class again. But we had to get a system down first. We are in section 6.3. I'm going to talk about grades and RenWeb at the end of class. A few of you guys are really interested in getting in missing assignments, which is good. That's what you're supposed to be trying to do. But we might need to talk about how you figure out what your missing assignments are and all those sorts of things. So we're going to talk about that at the end if there's time. Otherwise, we'll start class with that tomorrow. Kiddos, section 6.3. You guys already took notes?
Yeah.
Who or what did I name this function right here? Who is he?
form.
Okay, this is the form. That just means like the formula,
I know.
right? Hold on. Go back. Who is this called? Exponential function. Okay? Now hold on. What do you see in exponential function? Exponent, right?
Is this with a graph like
In- Good job. Exponential function. Jay, I need you to move your chair back. I let you move your stuff. Let's just give Johnny some space. Okay. Here we go. So exponential function has in it the form exponent. Now kiddos, where is the x in the exponential function? Where's the x? Yeah, it's in the exponent. Do you want to know why it's called what it is? Because the x or the variable is in the exponent. The variable, now in math, remember how I told you mathematicians are kind of lazy? I mean, we're not, but we want to use our logic to kind of shorten the process. That's the whole point of math. It's like computers. Doesn't that shorten the work that people have to do because it's all programmed in?
Yes.
Mathematical people write computer programs because they are able to think through the process anyway. They want to make things shorter. I'm going to write var for variable, okay? That's a common thing that math people do. So the variable is in The variable is in. Ooh, Ian, make sure we're writing notes, bud.
Oh, I'm sorry.
No, it's okay. We want 100% on everything that we can get. Variable is in the exponent. Now, kiddos, here's a couple more things. First of all, A is called the coefficient. Have you guys heard the word coefficient before?
Yep.
Yes.
So for instance, coefficient, now this is review, this is from, I don't know, a long time ago. If I was to give you something like 5x, this is just a random example, my question to you is, who is the coefficient? Johnny. I know, I can see it. Who's the coefficient in 5x? The 5. Who's the variable? The x, alright? So coefficient is just the number in front that's being multiplied. If you guys need to, because it will help you, you can put a little multiplication sign in between the A and the B. If I can actually get it in there. Do you see it? It's really tiny. You can put a little multiplication sign. Okay, you can say A times B to the x. And there's one more piece in this problem, and the one more piece in the exponential functions is called the base. So, A is the coefficient, B is the base, x is the exponent, okay? Now down below we got a few things as to what is allowed and what's not allowed. Characteristic number 1, what's allowed? B can be positive. What's not allowed? B can't be 1 and A can't be 0. But the nice thing is in homework, they probably won't give you too many impossible problems. That'd be mean, right?
Yes.
But we have this in our notes in case they give us an impossible problem. Number 2 says how do exponential functions, Angel, we did?
Yeah.
Number 2 says how do exponential functions behave? As the x terms add, the y terms multiply. As the x terms add, the y terms multiply. Now guys, that's a really hard thing because all the words. Can we look at a table? Oh, sorry, I had the wrong page. Can we look at tables?
Do you write that down?
Okay, if I were you guys, I would write down this table right here. But you know what, those words, let's not write the words, let's get the idea. Let's write down each of the tables.
So linear and
So no, just like
No, this
Let's start with exponential because, did you guys see in your notes how it said with tables as number 3?
yeah.
You're writing this in the with tables part because with tables, how can we tell something is exponential? Okay,
Every single time it doesn't like double, but it like repeats the number, so it just grows like super fast. You know, because it's not adding.
I have no idea what you're saying.
yes, but you said something kind of weird, Jordan, in the sense that you said it doesn't multiply, and it kind of does.
No, I said it doesn't. It does multiply.
Good.
That's good.
So as you're looking at these two tables, guys, linear is what we're kind of used to. We've been doing lines. Now, not that all of you guys are great at lines. We need to review lines for sure, right? However, coming back, we'll practice lines, but do you see the linear table
yeah.
and the exponential table? Question, how are exponential tables the same as linear tables?
Both add on the first.
They both, when you go from one x value to the next, you're adding numbers, right?
Okay.
Linear and exponential, you add numbers when you're making a table. Now sometimes, can't we go, instead of 0, 1, 2, 3, can't we go 0, 2, 4, 6? Sure. Or 0, 4, 8, 12? Sure. But whatever you're adding, we usually try to keep it so that we're adding the exact same number every time. But, and even though linear does that too, even though we're adding every single time in both linear and exponential, my question is, what's different in the tables? Jay?
Well, in linear you're adding, in exponential you're multiplying.
Good. In linear, every time the x adds, the y adds as well. Now, it doesn't have to be the same number. You guys notice that these are two different numbers? It doesn't have to be the same number. But what does have to happen is, as you add x's on the top, your y's are going to add by a constant, by the same exact number over and over and over. That's why we have a slope rise over run for lines. It's the same wherever you are on the line. Exponential functions are a little bit different. Do you guys already see the difference?
Yes.
Exponential functions, what happens as you go from one y to another y? They multiply. Now, is it still by the same number? Are the jumps the same? Yeah. The jumps are the same, but do you guys understand maybe a little bit better as to why? In the characteristics just a second ago, let me go back. I said, in exponential functions, as the x's add, the y terms multiply. Does that make more sense now? As the x terms add, the y terms multiply. So linear functions, you have to think about your pattern as add. I'm going to go ahead and write that pattern down. And you might want to write this pattern down because it's going to help you maybe in some homework problems if you recognize that linear, this is kind of review, so I'm going to put it in parentheses, it's up to you. Linear has a pattern of add, as x's add, y's add. So you guys tell me, how am I going to try to help you remember exponential tables and how they act? Instead of add, what do exponentials do? Good. We're going to say add, multiply. So if I can't spell multiply. Multiply. Got it. Whoop. You could do that, right? Mathematician, short and stuff. Sorry, I don't know where my little parenthesis went. Like that way over there. Okay, we basically just have examples. Okay? But let me go ahead and start. Let's not start with tables. They're kind of tricky. We'll get back to tables in just a second. Let's go ahead and just say, can you guys recognize which of the following are exponential functions? Someone raise a hand if they think they've identified an exponential function that we should circle. Who sees one? Who sees one? Angel, what do you see?
The second one at the bottom.
Second one at the bottom. This one?
No.
Oh, sorry, other one. That one?
Yeah.
Bottom left. Oh, that's a good way of saying it. Okay, Angel's thinking bottom left. Does anybody want to back him up and say yes or say no,
No.
or say a different one?
Different one.
Raise a hand, raise a hand.
Come on.
Yeah, Johnny, what do you see? First one. Okay, you're allowed to either take away one or you're allowed to add a new one. Josh, what do you see? We're working as a class. We're trying to get all the exponential functions
I
circled.
don't know if bottom right one is.
But you're thinking it is?
I don't know. It's on the.
You can go for it. It's on your radar. Okay, come on, somebody.
Go for it.
Oh, okay, we're circling all. Okay, I'm just gonna tell you right now, we're wrong.
Only two.
So let's make some changes. Come on, what can we change? Trippin, what do you see?
Take off all of them.
Yes.
Pick up all of them? Just take off one. Which one do you think we should take off?
Top right. Bottom right.
Bottom right.
Let's go from wrong.
Okay, sorry, you're still wrong. Jay, what do you think?
I don't know. You just said we're wrong.
Okay,
Take
what
off
do
the
you
top
think?
left. Top left, yeah, take off the top
Those
left.
two are right,
That's what I was thinking.
because
You're
Circle the
even
bottom
more
right.
wrong.
Circle.
Oh,
you add those two.
you're even more wrong.
It's top.
It's
Okay,
number.
Tyler, wait, Tyler, what do you see?
The top left you circle and then the bottom right you circle.
And you're saying take away this one?
No.
Oh, leave that one.
Yeah.
You're more right. But still, one thing is wrong.
Take that one away.
Molly,
Did you 4-7?
4-7. That's gonna go more wrong. But good idea.
Take off 2 3. I mean 2 3.
And the bottom left is wrong because the X is supposed to be the X.
Okay. Check it. You're right.
Oh,
Now wait. Jordan gave us a great description as to why we're right. Now hold on. This is tricky, right? That took us a long time, but let's go back to our notes. Exponential functions have a variable, have an x where? The variable is in the exponent. The x needs to be in the exponent. Now, why it got tricky was because, guys, do you see where they started putting numbers in the A spot and the B spot? Okay, we got to be careful. But let's go check those examples and make sure that we're tracking because it took us quite a while. Let's go back. Do you guys see the x in the exponent?
Yes.
Do you see the x in the exponent?
Yes.
Now, hold on. Technically, what's going on in this one? Isn't this -6
no.
times
That would be the
x?
base one.
Yes.
That's a line. That's a linear function. The x isn't in the exponent. The x is down below.
Okay.
How about this one? Isn't this one positive 2 times x cubed? Who's in the exponent? The x? No. Who's up there? The 3. Both of these are not exponential functions. The only exponential functions are the ones where x is everybody. Where? In the exponent. Does that make sense?
Yes.
Okay. Now let's keep going. Let's go practice with some tables. Let's just do number 1 and 2, okay? Let's start with number 1. you know what? Hold on. Didn't we have ways of remembering?
Yeah.
Linear. Do you remember the pattern? Add. Okay. Exponential. What was the pattern? Okay, good. Now you guys look at those tables. Careful, you have to be going left to right. Maybe it is. We gotta see which of the patterns match. Now hold on. Jay, what do you see?
I just have a more quick question.
Go ahead.
Dividing is the same as multiplying a negative, right?
Almost. Can anybody finish that statement? Jay made a really good statement. It's going to be the key to us figuring out number one. He said dividing is the same as multiplying by, and he said a fraction. He said a negative, and I said no. But a fraction. First of all, hold on. Let's not look at the bottom. Let's look at the top. Kiddos, what's going on in this table as you go from one? Okay, so far that's legal, right? But now we gotta ask this one. Now, you guys do see divide by 2. That's the first thing our brain sees, but that doesn't help us.
Multiplied by 0.5.
We can multiply it by 0.5 or multiply by, I like the fraction idea.
1/2.
Isn't 8 times 1/2 4?
Yeah.
Division is multiplication by the reciprocal. That's like a really snazzy math way of saying it. Division is multiplication by the reciprocal. So question. Number 1, if it's add, multiply, Robert, is that linear or exponential for number 1?
Number one is gonna be linear.
Well, let's try it one more time.
Exponential.
Why? Neve, why is number 1
Because it's
exponential?
not.
Yeah, Robert, shush. Neve, go. Yeah, it's multiplying on the bottom. And the only one that has add, multiply is exponential. So kiddos, don't just guess. Maybe they gave us 2 exponentials, right? What's going on in the next table? What are you adding by this time though?
4.
Adding by 4, adding by 4, adding by 4. What's going on down here? Ooh, subtracting by 1. How can we show that as addition? Adding
Adding negative 1.
negative 1, right? Adding negative 1, adding negative 1. Kiddos, is this one actually linear like you said? Yes. Why? Add. Now, hold on, wait. We're almost done. You guys have done a great job. I'm going to let you go probably 30 seconds after the bell, which is way better than the other 2 days. Wait. You guys did a great job today. But at the very bottom, numbers 3 and 4, I just need to ask you one question. When it says evaluate, wait. And it gives you x values. Guys, what do we normally do when it gives us x values and formulas with x's?
You plug them in.
Are you sure?
Yeah.
Are you positive?
Yeah.
Kiddos, if you want to take a picture on the way out the door, this is the homework due. Oh, where is he? There he is. The homework due tomorrow. Homework due tomorrow. If you have any questions on grades, you can ask me.
Bye, Miss Tuick.
Just when you come out.
You missed all of them.
Is yours have a perforation? Ah! Okay, there you go. That's great.
Yeah, I think I
You guys got the homework?
Wait, no.
No, I didn't.
Very.
Harry.
Yeah.
It'll be your Harry Potter.
Thanks, guys. Thanks for trying.
I know.
Do you want
I was just gonna say that.
Fine, Turner. Whenever that's the case, I just need you, because I like you telling me, but I like you telling me, this is right, just write parentheses absent on, that way I can.
Hold on, Austin. Hey, Austin.
This has negative 4 squared, this, like this. I don't know how to do that.
That one's kind of tricky, but what if we think about it? Think of it before, So that's the 7th root. Parentheses, exponents, multiplication. PEMDAS tells us to look on the inside first. The negative 4, we can't do much there. But as we move outside to the negative 4 squared, we technically make this seventh root of positive 16 y positive. Exactly. Now, we don't have to worry about that negative anymore. Well, we might backtrack a little bit, but don't we still want to figure out who 16 is? Yeah, we do our little like thing. Yeah, 8 times, sorry, I went the other way. But yeah, 8 times, or we can do this way. Either way, we end up with 2 to the power of, so we can change this to the 7th root of 2 to the power of 4. And now, if they wanted us to rewrite this, how would we take the radical and rewrite it as a fraction?
Oh, 7 over 4. You mean 4 over 7.
Because the way that is
So you don't have to like solve it like the rest. Okay.
But
I
I mean,
just solved
it is the same idea, but whenever I see that negative, I want to figure out, does he stay negative or does he go positive?
Thank you.
Is that cool?
Yeah.
Good job there. Okay, keep that. Thank you. You're welcome, Jay. See you later, bud.
Later.